All right, geometry, let's get down to business. We're doing section 4.3, which is on congruent triangles and mostly corresponding pieces, but a lot to do with congruent triangles. Ready, set, got your notes, let's go. So let's start by filling in some old theorems that we really need to look at, these review theorems here. We'll come back up to the top here second, but let's get these done. So definition of an angle bisector. If you're not sure where to find this, it's on page 23 in your book. An angle bisector is a ray or a line that divides an angle into two congruent angles. Go figure, congruence. So that means that this angle in here and this angle in here are congruent. In other words, angle LJK is going to be congruent to MJK. Similarly, definition of a segment bisector. So you got pieces that bisect other pieces. So AE here bisects BD at C. So what is it doing? A segment bisector is any ray, segment, or line that intersects a segment at its midpoint, right in the middle. And it divides a segment into two equal parts at its midpoint. So what are we looking at then? That means that BC is going to be congruent to DC. So these two pieces, those two pieces are congruent to each other. All right. Oh, whoops, forgot the theorems at the top. Okay, so we got some stuff going on. Actually, I'm going to come back to it after I finish these review theorems. Let's do these two, then we'll go back to that first page. It says definition of midpoint. The midpoint M of AB is the point that bisects or divides the segment into two congruent segments. That means that AM and BM are going to be congruent, and these are lines, so we should actually say like that. I think, did we do that on the other one? No, we didn't. We should have BC and DC, those are lines. Okay, right angle congruence theorem. This is pretty easy. All right angles are congruent. That's awesome. That means that angle H is a right angle G is a right angle H, and angle G are also congruent because they're right angles. And right angles are all 90 degrees. So let's talk about summarizing some of this stuff and moving on into our next piece. We have blank angles and blank sides are in the blank in polygons with an equal number of sides. So in other words, what we're talking about is the congruent pieces. So congruent angles and congruent sides are in the corresponding parts in polygons with an equal number of sides. Congruent polygons are if and only if their corresponding angles and sides are congruent. So we got congruent polygons are congruent, or we should say corresponding polygons. Two polygons. There we go. Two polygons are congruent polygons if and only if they're corresponding. Corresponding is a big word. What does that mean? Let's practice it. Let's see what's happening with this whole corresponding thing. I think that's going to clear up most of this stuff. So what we're looking at with corresponding pieces is how to match them together. So I'm going to help you here a little bit. I'm going to kind of count this off. If I look at this triangle as ABC, the other one I'm going to count in the same order. See how I started with A as a single, then B as the double arc, and then C as the triple arc? So I'm going to go 1, 2, 3, single, double, triple. D, E, F is what we would start with there. And what that means for me then is that these pieces match. The single A is going to match with the single D from the other one. Let's go ahead and change color here. That means that blue, so I'm going to do blue now, B is going to match E, and then F, in green here, F Oh, that was supposed to be green. F is going to match. Oh, did that kind of backwards. That's okay. I could have done it with F first, but C is going to match F. Now, similarly, we can do corresponding sides. So if I see this piece here as a corresponding side, that AB, what would that go with? Well, that would be the single side here, which is DE. And then BC is my double side, so I'll do that. That's my double mark side. Remember, these are line segments, so we got to put a line above them. Is going to match EF on the other side. EF. And then the final one, the only one we haven't done, is AC, which would match DF on the second triangle. Now, a really interesting way to look at this is just look at these letters from the original triangle statement, the triangle congruence. If we got like 1, 2, 3, and A is 1, B is 2, C is 3, and then we got 1, 2, 3, D is 1, E is 2, F is 3. So we got these things that match. The angles could be just 1, 2, 3, but the first ones here, this is like 1, 2, and then the second ones are like 2, 3, and then the last ones are 1, 3 for the line segments. So you can kind of just group them based on the original statement, which we'll see here in a second. So right now I got a polygon with PQRS and WXYZ. So I can almost just do this quickly. 1, 2, 3, 4. So if I go 1, 2, 3, 4, and WXYZ, that's 1, 2, 3, 4 as well, then P is going to match with the 1 from the other piece, and that's W. And then Q is going to match with the 2 from the other piece, which is X. And then R goes with Y, and S goes with Z. Similarly, let's do 1, 2, 2, 3, 3, 4, and 1, 4. So 1, 2, that's going to be PQ on the left one, and WX on the right one. And we'll have QR for 2, 3, and XY for 2, 3. And 3, 4 is going to be RS and YZ. And then the last piece here is going to be PS and WZ. Excellent. In a congruent statement, the order of the angles or vertices indicates correspondence or corresponding pieces. Corresponding pieces. So we saw this earlier. You know, the two polygons are congruent polygons if and only if their corresponding angles are congruent. We know that congruent angles and congruent sides are in the corresponding parts in polygons with an equal number of sides. Okay, let's look at some more examples now. Now actually using this information. So we got to identify all the pairs of congruent corresponding parts. So we got M, N, L, V, U, T. So let's do angles. We could do the 1s, 2s, and 3s. So angles, if we know that angle M is going to be congruent to the first angle from the other one, which is angle V. And if we do angle N, that's going to be congruent to the first angle from the other one, which is angle, or the second angle, which is angle U. And the third one is going to be angle L, congruent with angle T. I want to go ahead and mark that. So on here, that means that M is my first one, N is my second one, and L is my third. And I have VUT, so it's going to be first, second, third. So those would be those three pieces. Now let's do sides. Means we're going to have three pieces that are congruent, 3 pairs. Let's just fill these in. Okay, so the first one, I'm just going to pick one. How about LM? Right there. Now notice I went from L to M. That's 3 to 1. So that's like a 3-1 relationship. Then I got to do 3-1 on the other one, which is TV. Okay, let's pick another. How about MN? That's going from 1 to 2. So from 1 to 2 on the other one is VU. What's the only one I haven't done? A 2-3 or a 3-2. So that's going to be NL and UT. It's that easy, guys. I'm actually going to skip B. I want to move over to, well, I'll go ahead and do B. Let's look at this. So I got 1, 2, 3, 1, 2, 3, HIJ, TUV, HIJ. So that's 1, 2, 3, and TUV. So that's 1, 2, 3. Now to keep it kind of simple, I'm going to mark some of these as well. I'll do 1, 2, 3, like that. Now notice what I did here. If I were to think of this as 1, 2, and 3, from 2 to 3 I marked a single. So from 2 to 3 I got to mark a single on the other side. A single mark on the side. And then from 1 to 3, so that's from H to J over here, that's the double. And then the triple is the last one. So if I were to mark angles, angle H is congruent with angle, what would go with the H? Well, that's the 1, so the 1 from the other one is angle T. And then we have angle I, that's going to be congruent to the second one from the other one, from the second triangle. That's angle U. And then the third angle here is going to be angle J is congruent with, what's it match up with? Angle V. So that's my angles. Let's look at the sides. Okay, for the sides we got 1, 2, then we'll do a 2, 3, then we'll do a 1, 3. So 1, 2, that's going to be HI. High is congruent to, okay, that would be the first 2 from the other one, which is TU. 2, 3, that's going to be IJ for my second one. Is congruent to the second and third from the other triangle, which is UV. Then 1, 3, that would be HJ. Is congruent to TV. I like TV. You guys probably do too. Let's try the next one here. Very similar, very similar. And again, I think it's really helpful if you kind of label these as 1, 2, 3, 1, 2, 3. So CDE, that's going to be 1, 2, 3. Then IKJ, so that's 1, 2, 3. So that means that angle C is going to be congruent to angle I. Angle D is going to be congruent to angle K. And angle E is going to be congruent to the last one, which is angle J. And let's do some weird combinations. How about a 3-1, a 3-2, and a 2-1? We'll do this kind of backwards, just to show that it doesn't really matter. So if I'm doing a 3-1, that's going to be EC and JI. And then 3-2 would be ED and JK. And the last one, a 2-1, is going to be a DC, because I'm going from the second angle to the first, and a KI. So if I want to mark these, let's see, that means JK, or on this side, is ED on that side. JI over here is going to be the same as EC over here. And then the third one is the 3. There we go. Pretty easy stuff. Let's go ahead and do this one. Actually, I'm going to go ahead and pause the video, go ahead and write this one in, and you guys can check your answer. Go ahead and pause the video if you need to. Try it. I'm going to go ahead and work my way through here, but pretty quickly. So ready, pause. So we have the two angles that are going to be congruent. Not just equal, but congruent. And we got sides that are also congruent. Let's go ahead and label these 1, 2, 3. 1, 2, 3. LJK, so that's 1, 2, 3. And RST is 1, 2, 3. So LJK, 1, 2, 3, is going to be congruent to RST. It's that fast. Now I just got to do combinations here. So how about a 1, 2? That'll be LJ and RS. How about a 2, 3? That's going to be a JK and an ST. If I do a 3, 1, that'll be a KL and a TR. Excellent. We got more of this? I think we do. Identify all pairs of congruent and corresponding parts. I'm actually going to hold off on E and F here. Feel free for you guys to try them yourselves. Check with a friend or something. But let's just, in the sake of time, go and move on to the next one. Okay, using corresponding parts of congruent triangles. So what we're looking at now is, what do we know about corresponding pieces? So let's look at this one here. These two triangles are congruent. That means that this angle and this angle are the same. Well, I know that this right one is 90, so that means this other one's also 90. That means that 6x minus 12 is going to be equal to 90 degrees. Now it's just an equation for me to solve. I add 12 to both sides. I got 6x equals 102. And when I divide by 6, x equals 6 goes into that how many times? Let's see. 10 times, and then 42, so 17 times. That's a lot. Now it's asking me to find measure of angle GFH. Okay, so if I look at these two triangles, I know that this triangle here on the left has 21.6 in this corner, then 90. So that third angle has to add up to 180. So what's 21.6 plus 90 plus something equals 180? Well, I put those two together, and I would get 111.6 plus a question mark equals 180. So when I do this subtraction, we would get that that top angle is actually going to be 68.4 degrees. 68.4 degrees. And that's going to be the same as the top angle in the other one. Why? Because they're congruent and the congruent pieces match each other. So we're just trying to match the pieces up so that we can solve for their values. Let's try this one. Okay, so let's find the pieces that match. I got AB here, and what would that match on the other one? It looks like that would match. How about let's color code these. The blue AB and the blue DE are the same because I got AB and DE. So that means that 2x minus 2 is equal to 6. So I'm going to add 2, add 2. 2x equals 8. X equals 4. That was fast. All right, let's look at these other ones now. If I have angle B here, That's going to be the same as angle E here, so that's 53 degrees. But it's asking me to find the measure of angle F. And this is similar again, where we're going to have 90 degrees in the 53, and we got to find this missing piece there. That means that 90 plus 53 plus something equals 180 plus angle F, measure of angle F. Well, 90 plus 53, that's 143 plus measure of angle F equals 180. So if I subtract 143 from both sides, measure of angle F is 37 degrees. Excellent. All right, we're moving here pretty well. Let's keep this momentum going. Okay, now we get a little more complex. I see that I have angle P here, which is the first one, and angle L here, which is also the first one. So because those two are the same, I could actually set them equal to each other. So let's do that. 10x minus 3 equals 8x plus 12. So now I got to do some algebra. I'm going to add 3 to both sides. 10x equals 8x plus 15. Subtract 8x. 2x equals 15. Ooh, that's kind of messy now. So we're going to have 2x equals 15 divided by 2. X equals 7.5, or 15 over 2. LMN, so I'm looking then for this angle, which is the same as this angle Q. But how do I find those? Well, I know that this one in the middle, this is 90 degrees. And I could find these. I could find angle L and angle P. So measure of angle L, which is the same as measure of angle P, it's going to be equal to 10 times 7.5 minus 3, which is 75 minus 3, or 72 degrees. So that means that those would give me the red angle, or the purple angle. That's what I just found. But now if I wanted to find the red angle, which is measure of angle LMN plus the corner angle, or the right angle, 90 degrees, and the 72, so we got 90 plus 72, that makes 180 because it's all three of the angles inside. So I have this angle here and then the other two there. So I combine like terms, I get 162 equals 180, and then I have to add to the 162 the measure of angle LMN. Ooh, looks like I forgot the angle symbol on the last one. So when I subtract 162 from both sides, measure of angle LMN equals 18 degrees. So right here, this little piece, that's 18 degrees. And this piece here, that's 18 degrees as well. Excellent. Next. Ooh, we're going to prove some triangles congruent. Now, if you were to look at the notes, you guys should actually have some pieces here that say statements and reasons. So I'm going to help you fill these in. The first thing, 1A, what do we give it? P and M are right angles. So angle P, comma, angle M are right angles. That's given. A lot of times we can just put given for the first one. You don't have to always, but a lot of times you can. If those are given, then I know that angle P is congruent to angle M. How do I know this? This was something we looked at the beginning, where all right angles are congruent, and that's the right angle congruence theorem. Excellent. So what am I trying to do here? I'm trying to match all the pieces together. So I just proved that these two angles, P and M, are congruent. What else do we know? R is the midpoint of PM. Let's go ahead and do that. R is midpoint of PM. And when you're a midpoint, that means you split it up into two congruent pieces. So that means that this PR and this RM are actually congruent. So PR is congruent to MR, Mr. Let's do the other givens now. So I got PQ is congruent to, what is this, MN? And then we also have the QR is congruent to NR. And both of those are just given. So 4B is given, 5B is given. But there's one more. And it's the last angle. It's this angle here. There's actually two different ways you could do it. Oh no, we have two more. So let's do this one. 6A. We know that QRP is going to be congruent to angle QRP is congruent to angle NRM. Why? Well, those are across from each other at an intersection. That's vertical angles. So because of vertical angle theorem, those two are congruent to each other. Finally, last one, and then we can get to the actual finale of the proof. It's this third angle here. Q and N. Angle Q is congruent to angle N. Why? Because the first two are congruent, so by the third angle theorem, the third one is also congruent. The finale is here. Step 8. Oh my goodness, this took quite a while. So we are going to write the finale. Triangle PQR is congruent to MNR. Why? Definition of congruent triangles. Let's see if I can even use my symbols correctly. Definition of congruent triangles. That was long. Do we have another one? I think we do. Okay, again we got the statements and reasons split up. So statements, reasons. Let's talk our way through it. YWX and YWZ are right angles. YWX. So this one wasn't even marked, but they're both right angles. So given angle YWX and YWZ are right angles. That means they're congruent. That means angle YWX is congruent to angle YWZ. Let's look at the second step here, 2A. We know that YW bisects angle XYZ. So YW bisects angle XYZ, angle XYZ. Oh wow, I am jumping way ahead here. Let's go back a second. This was given, which told me that they were congruent. Angle YWX is congruent to angle YWZ. Where were we? Oh yeah, janitor walked in. Cool guy. Let's get back on track. Why? Because the right angle congruence theorem. Next, now we can jump into this bisector thing. So YW is going to bisect angle XYZ. How do we know that? Well, that's definition, or that's given. That's given. But what does that do for us? That makes things equal. That means that this piece bisecting right here is going to make these two pieces equal. So XYW is going to be congruent to ZYW. And that's definition of angle bisector. let's do another one. What else do we know? W is the midpoint of XZ. So that means that these two pieces are going to be equal. So W is midpoint of XZ. So 5B. And that's given. But that makes those two halves equal. So 6A. That means that XW is congruent to ZW. And that's definition of segment bisector. Or no, not definition of segment bisector, definition of midpoint. Okay, let's look at another one here, 7A. What else do we know? Oh, we're given this piece, XY is congruent to YZ, 7B, that's given. And we already got two angles. We got this angle and this angle, so the third angle is automatic, 8A. That means, what's the third angle? It's going to be this one out here, X and Z. So angle X is congruent to angle Z because it's the third one. We already got the first two. Third angle theorem. Oh, this is a long proof. We still have 2 steps here to go. So the next one that we're going to say, what do we have? Oh, YW is congruent to itself. That is weird, but whenever you have something congruent to itself, because we have to use it here twice for both triangles. Like if I were to draw 2 triangles, one on the left, one on the right, I have to use it twice, once here and once here. And we have to use it twice. That's a reflexive property. Reflexive property of congruence. Now that we have all 3 sides, all 3 angles, that means that we have the finale. Triangle XYW is congruent to triangle ZYW. And that's definition of congruent triangles. Wow, that's a lot. Okay, so now let's go back to some simple stuff. Let's just look at the pieces and see if we can just write the triangle congruence statements. So the first one, I'm going to go 1, 2, 3. So 1, 2, 3. And then I'm going to go 1, 2, 3 on the other one. 1, 2, 3. So that's going to be X, Y, Z, and B, C, D. That was pretty easy. Let's look at this next one. I got A, C, B, triangle A, C, B, because I'm going to go 1, 2, 3. For the other one, now I got to go C, A, N. So that's congruent to triangle C, A, N. All right, for this next one, I'll do the 1, 2, 3 again. 1 for the Y, 2 for the Z, and 3 for the X. And then I have 1 for the W, 2 for the V, and 3 for the X again. So the first one is going to be Y, and then Z, and then X. And what goes with those pieces? The W goes with the Y, then the V, and then the X again. Excellent. Okay, so we're gonna probably wrap these up pretty quick. How many more do we got? We got a few more. Let's get these worked out here. So again, I got 1, 2, 3. So that's going to be Q, R, S is going to be congruent to another triangle, which starts with Q again, then goes to F, and then G. So Q, F, G. All right, for the next one, we have 2 triangles, triangle, triangle, they're congruent. We'll have L, K, V. So L, K, V. It's going to be congruent to K, L, M. K, L, M. I'm going to go ahead and skip the last one because hopefully by this point you guys are seeing how I'm figuring this out just with the single, double, and triple arcs and just finding the corresponding sides and writing them in the same order. Now I didn't have to go 1, 2, 3. I could go 2, 3, 1 or 2, 1, 3 or 3, 2, 1. There's actually 6 different ways you could write it. But as long as you have the pieces matching in each one, then you're fine. So let's look at this one. This is really similar to actually what we just did. So you look at this 2x minus 16. We know that's corresponding here. So if we wanted to find x, we would do 2x minus 16 equals 90. Then we solve for x, so we add 16, and we got 2x equals 106. When we divide by 2, x here equals 54. Excellent. Okay, now for the other one, this piece says 49.3, so then what are the other two pieces here? Because this over here, this would be 49.3. So that other piece is going to be 90, or 180 minus 90 minus 49.3. So 90 minus 49.3. What would we get? Well, that should be, let's see, that's going to be 40.7. And that's what we need to find here. DBC is going to equal 40.7. Sometimes it helps just to figure out all the angles and then see which one they wanted. In this case, they wanted the 40.7 degrees. All right. Mark the angles and sides such that they're congruent as they say. So let's go in the order they say, F, G, E. So I'm going to start with F, and then G, and then E. FXW means I start with F again, then X gets the double, and then W gets the triple. So now if I'm going to do, let's kind of do these. GE will be my first one. So that means XW gets my first one on the other triangle. Then for my second one, I'll do FE, the first and the last, which means I'm going to do a 1, 3 for the FW, so that's a double. Then the last one is here, 1, 2, 3, 1, 2, 3. Excellent. All right, JKL, so that's going to be 1, 2, 3. And then KJH, that's going to be 1, 2, 3. So JK, that's 1, 2, 3. And KJH is going to give me 1, and then 2, and 3. Now again, if I wanted to mark these, here's a shortcut too that I've been using in my head, but you guys can spot. If I go across from the 1, that I can make a 1 there. So across from the 1. Across from the 3, which will be this one in the middle. And then the last ones, the only ones left here are, whoops, take one of those back, are the 2 on the left side and the 2 on the right side. Ooh, this next one's not so obvious, so let's be really careful with it. We got 1, 2, 3, 1, 2, 3. Z, Y, X. That's 1, 2, 3. 1, 2, and 3. JXL, that's going to be 1, 2, and then 3. This is very different because you wouldn't have expected those to switch like that, but they did, according to the triangle correspondence in the first statement. So now when I mark these pieces, they're a little bit different. This is how the markings should look. Things kind of switched around. So check what you have, see if you get the same thing. Only got a couple more questions here. Let's get really specific. So if this is saying GFH, and I'm going to go ahead and mark those, 1, 2, 3, 1, 2, 3. And it's asking me for what matches FH. That would be, so I'll call this GFH 1, 2, 3. And the other one, LKM. 1, 2, 3. I'm looking for the piece that's the 2, 3 right here. So I need the other piece that's the 2, 3, which is the KM. Now a little note here, if you wrote MK, technically that's also true. Normally we write it in the same order that it was written from the original one, but you could write it in either order. All right, let's look at this next one. We got 1, 2, 3 KJI, so 1, 1, 2, and then 3 for the I. And then 1, 2, 3 for the RST, so 1, 2, and 3 for the T. So we're looking at J, which is the second one here. So I want the second one, the S. So that's going to be congruent to angle S. All right, for this next one, we got angle J. That's going to be my first one. I'm going to shortcut this one. I know it's the first one in the first triangle, so it's the first one in the second triangle as well. That's going to be angle I. I didn't even need to look at the picture because the congruent relationship here, the statement of congruence, tells me exactly which pieces should be matching. Okay, I think we only have one more set of slides here. It's proving triangles congruent. And actually, I'm going to leave this one off. If you do want to check on this one, just come into class and ask about it, or you can check on somebody else's notes. But we're going to call it a day, call it a night. So good night, and sleep tight. Don't let the bed bugs bite.